My name is Isabel. I'm a CEO and co-founder of Cellugy.
And my name is Debbie. I'm the CSO and one of the co-founder of Cellugy.
So we come from Spain and Indonesia, and we have made a company in Denmark. So we are a very international team.
Então, conta pra gente o que é esse projeto, o que vocês estão desenvolvendo.
In Cellugy, we are rethinking about the packaging basic principle. So we are redesigning a monomaterial that can have the basic functionalities like plastics. So our invention called EcoFlexi. EcoFlexi is an all cellulose-based material that made from biocellulose. So biocellulose is not typical cellulose that you have in the tree. We grown the material, and this biocellulose can be made from non-food sources or feedstock, such as fruit pomage that you have it from the fruit juice company. So kind of we have basic principle of industrial biosymbiosis with when other industry waste is our resources.
For example, the peels, the seeds, these things that are considered as waste right now, that these food makers actually are not using for anything or for something that has a very low value for them. So that's why we team up with them so we can provide a circular economy solution to their products. And in some cases, it can be actually used to repack their own products because they produce food. So in that sense, you contribute to a circular model.
So what kind of plastic does it replace? What kind of applications, like what properties it has and compared to what we have now?
Yes, so I think when I present our solutions, and actually it has more potential as from it seems, because biocellulose we can use it as it is as films, so because it's transparent, so you can make it as a bag, you can pack a solid food or solid organic soap, for example. And this biocellulose also can be used as a strengthener for the paper packaging, so that the paper packaging they will need less material, but they make the packaging stronger, but it's also lighter, so they save cost, they save resources from their side. And this type of biocellulose also we can make it as a lamination of paper. If you know, like the paper tray for the food, they have some kind of lamination for the water barrier properties, and that lamination actually come from PET. So you need to separate between the paper and then the PET and then make it, so it's not 100% biodegradable. If they use our material as a lamination, then we will make those paper the 100% biodegradable, compostable, while still have the water resistancy properties that they need. So, I mean, the potential is huge to replace plastics that seen and not seen. You see it as something that can be seen, the plastic, single-use plastic, the films. But what you don't see is also those plastics in the paper packaging that they use as a strengthener and they use as a laminations. Those things that you don't see, we can replace so that we can make it like 100% biodegradable, recyclable, and compostable as well.
And is it compostable as well?
Yes, it is home compostable. We are running we already did the certification in OWS for OK Compost.
Mm-hmm. Nice.
So we basically can tuck it under the soil, wait for 4 months, it will disappear. Well, you will not see it in 4 weeks, but I mean it will be completely biodegraded in 4 months.
Even at home or any place?
Yeah, our top priority was to make it at ambient temperature, so it biodegrades at ambient temperature, because at the end of the day, I mean, the benefits, for example, that bioplastics are bringing to the society, saying that it's compostable, they still require a collection system because they only degrade from 60 degrees and very specific humidity conditions that you don't find in the environment. So at the end of the day, okay, they might be a more sustainable solution, but the end of life is still not the perfect one, right? So that's another of our priority areas, was to make it biodegradable at room temperature.
Mm-hmm. and if you can explain for people who don't know the science part, what happens then? Is it a bacteria that grows with this? Can you explain how it works?
This is our raw feedstock, is the fruit waste. And then from fruit waste, what we extract is sugar. So this sugar is any type of fermentable sugar that we can use as a medium of our microorganism cultures. And then the sugar goes to a fermentation process. So fermentation process for you that it's not familiar is like when you brew your beer or when you make yogurt or cheese. So fermentation process, and we got a wet film. This is wet film. Yeah. So we have this wet film, or we call it hydrogel, of biocellulose, and then we do the chemical processing and drying. Then you have ecoflexi seeds. And these ecoflexi seeds can be customized with different functionalities. For example, different oxygen barrier or different water resistance degree, or you want to make it colored, or you want to print on it, or you want to make it fully transparent. So it depends on what customer wants. We can customize it.
Wonderful.
So ecoflexi will, when you put it in the soil, ecoflexi will be disappearing kind of in 4 weeks and will be fully biodegraded at home compost for around 4 months. So you will not see it anymore. It will be just the food for the plants nearby. So yes.
Wonderful. And the leftover of the process, you said it's just vinegar.
It's the fermentation process. So basically, we have the wheat film, and this is only the vinegar. So this vinegar actually can be reprocessed back to the fermentation process for another time medium. So we kind of decrease the water consumption in the future. We are thinking also how about to sell it, because it's just like another source of revenue, because it's probiotic bacteria that we are using, so it's completely safe for food application as well.